Okay, section 5. There are 3 ways to solve a system of linear equations. Well, 4 if you count matrices, but for now, these are the basics. For today's video, we're only doing 2 linear equation systems, but know that you can use these methods for any number of systems. First method is to just graph the lines. You can use a graphing calculator, type the linear equation, and see the point the lines intersect, aka the solution. The point they meet is the solution to both equations. That means that if you plug in the x value and y value of that point into both equations, it'll work. Substitution, basically you have your 2 linear equations, and what you want to do is take any of the 2 equations and isolate either of the 2 variables. Then plug that into the other equation, solve for the variable, and plug that variable into the equation. I don't get it. You know what? It's just better if I show you how that works. Okay, so we have x plus y equals 5 and 2x plus 3y equals 13. First, choose your equation, the top or bottom, first or second, choose one of them. I'm choosing the easiest one where we can get the variable by itself, the easiest / quickest. Now pick the variable in that equation you want to get by itself, meaning we're either going to turn this equation into y equals something or x equals something. It doesn't matter which variable we do, it's fine if we do any of them. Also, fun fact, if you're isolating y, you're turning that equation into slope-intercept form. Get x by itself because I want to do it. Okay, so we are getting x by itself, and we do that by doing the opposite operation that's happening to x. So if we're adding y to x, we need to subtract y. So subtract y from both sides, and we get x equals 5 minus y, aka negative y plus 5. Now for the second step, we plug that into the other equation, 2x plus 3y equals 13. We have x equals 5 minus y, so plug what x equals. Plug that into the second equation's x, as shown in the picture here. Now solve for y by distributing and combining like terms. When we say combining like terms, we mean like combining the same stuff, like the same variables, the numbers, etc. So then we get 10 plus y equals 13, and for our third step, now we are going to solve for y. So what's a number that if we add to 10 will give us 13? We're going to subtract 10 from both sides again, because opposite operations. We're adding 10, so subtract 10, and we get y equals 3. And we get y equals 3. The last step. We know what y now is, so plug into any of the original equations. We're going to do x plus 5, because squared out says it's easier, so we're going to do x plus 3 equals 5. Solve for x by subtracting 3 from both sides, and we get x equals 2. The solution is 2, 3. And we can check this by plugging in our values. X equals 2, y equals 3. So we're going to put those values in there. For the top equation, we get 2 plus 3, which is correct. And the bottom, we get 4 plus 9 equals 13, which is correct. The substitution method is helpful if you could easily get the variable by itself. But sometimes it's better to do this next method, elimination. Okay, here are the steps to do elimination. You add or subtract the equations to get rid of the variable, and the leftover variable you solve for. Then plug in the leftover variable's value into any of the original equations to find the original eliminated variable. Guys, again, it's better if I just show you. Yup, okay. Okay, so we got this system of equations, 4x minus 2y equals negative 8, and 2x minus 5y equals negative 12. The equations are in standard form. Okay, first step, which variable we want to get rid of? X. Get rid of x. Okay, so we want to get rid of x. What we do is we want our x terms to be the same value, but just with different signs so that the opposite signs cancel each other out. So in this problem, we have 4x and 2x. Squared out, why'd you give us such a hard problem? Okay, well, we want our x terms to be 4x and negative 4x, because when we add those two, we get 0. So they just cancel each other out and the x is eliminated. For this specific problem, because we don't have that yet, we got to turn it into that. So multiply the bottom equation by negative 2, so that we get our equation to have this, that we have the same but opposite sign x term. Now we can eliminate. Add the equations together. So 4x minus 4x cancels. We get, and so we add negative 2y plus 10y, which gives you 8y, which equals negative 8 plus 24, so 16. Now for the second step, we have 8y equals 16. So divide by 8 to get y by itself, and we get y equals 2. Now for the third step, use the variable we know to find the other. In other words, we know y equals 2, so use that to find x. Basically, the variable we know into the first original equation, so we get 4x minus 4 equals negative 8. Get the x term by itself, so we add 4 to both sides with the equal sign, and we get 4x equals negative 4. Then divide by 4, the last step, before we get x equals negative 1. Okay, let's plug in our values and check if this is correct. And we get negative 8 equals negative 8 and negative 12 equals negative 12, so our solution is right. All these methods work, it's just what you prefer / find the easiest to do for the problem you get. Okay, now for the last section. Yippee! We're going to briefly cover parallel and perpendicular lines. For more information about those, see the video link in the description. Okay, so if lines are parallel, that means that the lines have the same slope but different y-intercepts. And perpendicular lines basically have opposite reciprocal slopes, so opposite signs, flipped slopes, and when they meet with each other, they make 90 degrees. Here's an example of parallel lines. Notice how they have the same slope but never touch because of the y-intercept. The red line's y-intercept is at 0, 0, the origin point, while the blue one is at 0, -1, so that is a huge difference. Now, let's take a look at the perpendicular. This time, the points intersect, but they form 90-degree angles. Don't rely on visuals, though. They can trick you. Notice the slopes of the lines. The red line has a slope of 3/2, and the black line has a slope of 2/3. So the reciprocal/flipped version, and it's negative, so we have an opposite reciprocal slope. That's how we know for sure that the lines are perpendicular. Now, say you get a problem that asks you to check if the lines are perpendicular or parallel, but the equations aren't in slope-intercept form. In that case, you can change the equations to be in slope-intercept form to compare the slopes, because that's to tell you if it's parallel, perpendicular, or if they intersect. Not only do we have parallel and perpendicular lines, but we have lines that have 0 slopes and undefined. For 0 slopes, the slope is 0. The rise of a run is 0, so it's just going to be a straight horizontal line. Horizontal is left, right, not up and down. The equation for a 0 slope line is y equals a number, aka the y value of each point on the entire line. Now, undefined is the complete opposite. Undefined is an undefined slope. You get rise over run of 0, 0, which is undefined. So what that means is you have a vertical straight line, so up and down, and its x equals a number. The number being the x value of all points of that line. Undefined and 0 sloped lines are perpendicular. Lastly, when we're solving linear equations, the solutions can be messy. Messy is an overstatement. Quit scaring them. Basically, if a system of linear equations has infinitely many solutions, it means there are many points of intersection that work for the lines. This happens when the lines are the exact same thing, okay? And as for no solutions, it's in the name. No solution, no point the lines intersect, and this happens when the lines are parallel to each other. We'll start with no solution equations. We have 2 choices for how to solve this problem. Option 1, we can change the linear equations into slope-intercept form, which will let us see if they're parallel because of same slopes, different y-intercepts, or option 2, we solve for the solutions either with elimination or substitution. Both work, but for this problem, I'm personally solving with substitution. Okay, so we got to isolate our variable, but we already have that, so now we just plug what y equals. So what y equals into the other equation and solve from there. Here comes the fun part. Okay, so we get -10 equals -8, and there are 2 possibilities. 1, we either did the math wrong, which isn't what we did, I double checked. So it's the other possibility being there's no solution. If you get something false, your system has no solution. Let's do option 1 for the same problem. We're going to change our equations to be in slope-intercept form. We already have y equals 2x plus 5 done for us, so we need to do it for 4x minus 2y equals -8. What I'm going to do is add 2y to both sides so that the y term becomes positive. Then I'm adding 8 to both sides, then dividing by 2 to get y by itself, which equals 2x plus 4. And yup, we have the same slope, but different y-intercepts, so no solution. And you can see it here graphed as well. Now this one's for infinitely many solutions. One of the ways you can check if it's infinitely many is to see if the equations share a common factor. For example, I can divide the top equation by 3 to get the bottom, and then I can multiply the bottom equation by 3 to get the top one. This shows infinitely many, but I don't recommend relying on this one a lot, as the numbers can get tricky sometimes, and the system of equations aren't always in the same form. In this one, both are in standard form though. Definitely use this method too, solving with substitution or elimination. Okay, so let's go ahead and solve this with substitution or elimination. I'm doing substitution because y is already isolated, so I'm going to plug what y equals into the green equation. Okay, now we're distributing, so 2x minus 2x cancels, and we get -4 equals -4. We either did bad math, just checked it, we're good. Okay, so we're good there, or we have infinitely many solutions, which is exactly what happened here. When we have infinitely many solutions, it's just the same equation for the 2 linear systems, as shown by the graph. And -4 equals -4 just tells you that it's infinitely. Okay, to quickly recap, linear equations follow a pattern, an incline. That incline is the slope. The slope is rise over run. You can use the slope formula to find it too. The pointed line crosses the y-axis is the y-intercept, the b in slope-intercept form. And the point it crosses the x-axis is the x-intercept. There are different forms of a linear equation mx plus b, which is slope-intercept. Y minus y1 equals m times x minus x1, which is point slope, and ax plus by equals c, which is in standard form. You can solve systems either by graphing or doing substitution or elimination, whichever you feel is best. Parallel lines have the same slope, different y-intercepts, so no point of intersection/solutions. Perpendicular lines have opposite reciprocal slopes, and equations that have infinitely many solutions are the same line when graphed. Well, that's that from the bio theorem. Stay tuned for more. See ya!